In our previous studies in this course, we've talked about probability distributions, right? We just talked about all sorts of things related to probability, but there was that concept of probability distributions. And we saw, there are two types, discrete and continuous probability distributions. And we worked a lot with discrete probability distributions where, you were given a table of outcomes and then you had to make sure that all the probabilities for the sample space added up to 1. Okay, big deal. Okay, we didn't see that many examples of continuous distributions, mainly because they are really tricky to calculate because remember, for continuous distributions, probabilities are measured as areas under the curve. Okay, but there is one other continuous distribution or continuous probability distribution that we really need to know, and it's called the normal distribution. Okay, and this distribution is used all over in statistics. And in fact, it's kind of the fundamental distribution for many of our theoretical landmarks that we're going to see coming up. But what is a normal distribution? Well, we know it is a density curve, so that when we draw it, it's going to be some sort of curve, right? We had a graph looking like that, for example. Or, we saw an example where it was actually looked a little bit like a triangle and then a rectangle. Okay, and then, we measured the area underneath there. Okay, so this curve, though, that makes up the boundary, that's the density curve idea. Okay, when we talk about a normal distribution, it isn't, this straight line and then a flat line over. Okay, instead it has three defining characteristics. Okay, first of all, it is symmetric. Okay, which means you can fold it in half and it will mirror on top of itself. It is also unimodal, meaning one mode, one peak. Okay, one peak. Okay, and the last and most famous characteristic is that when we look at it, it looks like a bell. So I just say it's bell-shaped. Okay, and so these to help me remember the three characteristics of a normal distribution or a normal density curve, I remember SUB, sub. Okay, and so when we create a normal distribution by hand, okay, we have to keep these things in mind. So we know that there's kind of one peak, okay, and it's going to be symmetric, okay, so I can start kind of going down, down, and I'm making sure that it is bell-shaped. So it looks something like this. Okay, and they can vary. And so we could have something like that. We could have it a little bit fatter on the ends and less peaked. Okay, we could have the peak over here, right? But in general, that's kind of what a normal density curve looks like that corresponds to a normal distribution. So we can have many different normal distributions, right? And so here you can see different colors representing the different normal distributions, okay? And the only thing though is that most often we don't want many different normal distributions in context, right? We need a specific, okay, specific normal distribution. And for that reason, when we are working with a specific normal distribution, we need to specify two parameters, as you can kind of see up here in the legend. We need to specify mu, okay? This is the Greek letter mu, okay? And that just represents population mean, okay? We've seen that parameter before, and we've also talked about sigma, and they use sigma squared meaning variance, but this is just the population standard deviation. Okay, so Greek letters mu and sigma represent those two things, and so then when we talk about any sort of normal distribution, we have to specify the values of mu and sigma, the mean and standard deviation respectively, to fully describe the normal distribution that we're interested in. And so we use this notation here that I'm highlighting, x and then squiggle n mu sigma, and we read this as x follows a normal distribution with mean, mu, and standard deviation sigma. You need to know that language. Make sure to kind of connect the two. If you need to put it on a flashcard, hey, great, but you need to know this notation and the language that corresponds to it. Okay, and so when we, I guess how these are important is that the that the value of mu is the value that is right smack dab in the middle. Okay, so let me maybe return to my sketch here and let me just get rid of some of these. But that value right smack dab in the middle, that's going to be our mu. Okay, this also happens, so this is the population mean, but it's also the mode. Okay, that's kind of interesting. And the standard deviation is kind of right where it go, or like one standard deviation out. So if we were to do like mu minus sigma, it'd be where the curve starts kind of transitioning from bending down. You can kind of see like here you could imagine a bowl. A bowl like filling, well, this would be a hat in this case. We would want to go from where it switches from being a hat to more of a bowl shape. So that would be mu minus sigma on the left, and then over here we could go out and we would add the standard deviation. So this would be, you know, mu plus the standard deviation. And so that's just kind of one interesting trait about this curve, is where it starts changing its bending is where it's one standard deviation from the mean. Okay, so we're going to get lots of practice drawing these normal distribution curves, or normal density curves, I should say, making sure to put the mean in the middle and then kind of measuring out standard deviations. But one final thing is that we know how to do the mean, or the mode and the mean, right? That's smack dab in the middle. But what do we say about the median? Okay, remember the median is the 50% mark. Okay, well, I'm going to let you think about that for a minute. So where's the 50% mark on this curve? And the answer is right where the mean and median are, or the mean and mode are, I'm sorry. Because again, it is symmetric. So whatever the halfway part is where it should fold, and that folding point is right where the mean and mode are. So nice other property about the normal distribution. The mean, mode, and median are all the same.